Hello, today we're going to talk about variance and standard deviation. So whenever we use the range and the interquartile range as measures of spread, only two values are going to be taken into account each time. So for the range, we only focus on the max and the min. For the interquartile range, we focus on the upper and the lower quartiles. So if we want all the data values to be taken into account, we need to use the variance and the standard deviation. So the formula for the population variance is here. So what this is basically saying is that your population variance is the sum of the sum of the squares of the differences between your x values and your mean divided by the number of data points you have. So basically, when we read this formula, we know that we first have to find the mean, and then we have to subtract the mean from each data value, and then we need to square the differences, and then we need to add the squares, which is where the sum part comes in, and then we need to divide by the number of values that we have here. So that is how we will find the variance. Now, when it comes to the standard deviation, in the standard deviation formula here, you should be able to see that the only thing that's different between that formula and the population variance formula is the fact that you see a square root sign. So in other words, the standard deviation is nothing but the square root of the variance. So let's look at an example. So for this example here, it says that we want to find the population variance and standard deviation for the data set. So we have our values, so we're going to put those in the table for X, and I'm using this table to keep me organized. So we're going to have 25, 68, 93, 30, 42, 35, 67, 77, and 50. So now we need to find out what is our x values minus our mean. So the first thing that we need to do is we need to find our mean. We know we can find our mean by hand by adding up all the values and dividing them by 2. Or what we could do is we can use the calculator to find our mean, which is what I'm going to do here. So here, when I do that, I'm going to have 25, 68, 93, 30, 42, 35, 67, 77, and 50. So once I do that, I'm going to go to stat and I'm going to go over to calc, one variable statistics. My list is coming out of L1. There is no frequency list. And I see that my mean is the X bar. So my mean is 54.1. All right. So now I need to subtract and find the difference between each x value and my mean. So I'm literally going to take each x value and I am going to subtract 51.4 from it. So I'm going to have 25 subtract 54.1, and I end up getting negative 29.1. Then I'm going to do 68 minus 54.1, and I end up getting 13.9. Now, an easy way that you can end up doing this and you let the calculator do it for you is that when you press stat and you go to edit, if you go over to the L2 column, if you scroll up to L2, you can tell it what you want it to do to each value. So I'm going to type in L2 is equal to each value in L1, those are my data values, minus my mean, which is 54.1. And when I do that, I see all of those differences come down, so I can just write them in. So that's a little trick there that you can use in the calculator, or you can just calculate the differences by hand. So now once I do that, I want to square these numbers. So I want to square negative 29.1, and that's going to give me approximately, it's going to give me 846.81. I'm going to use the exact value, And then I'm going to have 13.9 squared, which is going to be 193.21. And just like I did before, I am going to go to stat edit, and then I'm going to label L3, and I'm going to say that L3 is equal to L2 squared. So now I would just write these numbers down in the table. So here I'm going to have 1513.21, 580.81, 146.41, 364.81, 166.41, 524.41, and then 16.81. So once I do that, all I have to do is find the total number, which means I can just add all of those up, or I can work smarter, not harder, and then I can just go to stat, go to edit, or excuse me, stat, and go over to calculate and one variable statistics. But I only want to find the sum of that last column, which was L3, and then I can go down here to calculate, and then you will see that the second line, it has the sum of x basically, and the x values came from L3. So if I wanted to add up all those numbers, I would see that my total would have been 4,352.89 here. So that is my total here that should go there. So now, based off of the formula for for population variance, all I have to do is take that sum and divide it by how many numbers I have. So I would know that my variance here would be equal to 4,352.89 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. And when I do 4352.89 divided by 9, I end up getting that my variance is approximately 484 in 3 sig fig. And then remember that your standard deviation is the square root of your variance. So my standard deviation will end up being the square root of 484. And the square root of 484 is approximately 22. Okay. If you wanted to, you could have actually taken the square root of the raw form, and if you would have done that, that would have been the square root of 483.65 and 44444, and then you will see that in 3 sig fig it will have still rounded to about 22. Now, the way that you can find your standard deviation in the calculator is if you press stat and you go over to calc one variable statistics, you're going to take it back to L1, because you know that all of your x values were in L1, and then you can go down to calculate. Standard deviation is the symbol that looks like this. It's the sigma with the x on it. Right above the n equals 9, that is the standard deviation there. And you see that you get the same answer to 3 sig fig, it'll be 22. Now, if you are using a calculator, if you have the standard deviation in the calculator, in order to find your variance, all you have to do is do the opposite of square rooting, which is to square. If you take your standard deviation and you square it, you should get back the variance. Okay? So if you have any questions on standard deviation and variance, please let me know and I will be more than willing to assist you. Have a great day.